How's it, grade 12s? Today we're going on to geometric sequences. So just like with your arithmetic sequences, you either add or subtract, the same thing. With your geometric, we are going to be multiplying. Now I spoke to you guys about this the other day, about dividing and stuff like that. I don't want you to divide to get from term to term to term, rather multiply. And I'll show you in a second why, okay? If we just go through the notes here quickly, geometric sequences. If we divide any term in the sequence 3, 9, 27, 81 by its previous term, in other words, if we take 9 divided by 3, or 27 divided by 9, or 81 divided by 27, we will always get a value of 3. Now, in general, Tn plus 1 over Tn is equal to 3 is the common ratio. Don't worry, grade 12, so I'm going to summarize it on the next page. A geometric sequence is any sequence with the general term Tn with a common ratio, where r is constant, and that would be your common ratio, just like your common difference, which is d for an arithmetic sequence. The constant r is called common ratio, and T1 is usually denoted by a, very similar to the arithmetic sequence. Okay, so what I want you to take from this slide is you're going to take the general formula for a geometric. Okay, now I just want to make a note here. You remember for an arithmetic, to find d, we said T2 minus T1, or we could say that T3 minus T2, and it goes on, okay? For a geometric, we've got this common ratio, and that would be T2 divided by T1, which would be the same as T3 divided by T2, and so on. Okay, so that is how we do it for a geometric. That is how we do it for an arithmetic. Now just remember, your a is always your first term, so we know that T1 is equal to a, and n is just your term number, whichever one you're interested in. Okay, so just take that down for me. Right, so if we go through the first example here, it's saying determine the 11th term of the geometric sequence 5, 15, 45. Okay. And it goes on and on. Okay. So if we take this divided by this, we can see we multiplied by 3. If we take 45 divided by 15, we can see that we multiplied by 3. So we can see that our common ratio is 3. We're multiplying by 3 each time. Now, I just want to do a side thing here. I just want to explain why I do not want you guys to divide. So let's just say that we have this sequence instead. And it goes on and on. So what you can see here now is you can see if I take 15 divided by 45, I'm multiplying by a third. Likewise, to get from 15 to 5, I'm multiplying by a third. Now, the reason why I don't want you to divide is because if you divide by this fraction here, you remember you have to tip and times it. So what you're actually doing is you're multiplying by 3, and that does not fit the sequence. So that's why I want you to try and avoid the dividing and rather just multiply by your common ratio, and you can never go wrong. Okay, so that's just an example why I don't want you to divide. Right, so we need to find the 11th term. So I have to use my general formula. Tn is equal to a times r to the n minus 1. Okay, so we have what our a is. It's 5. We know what our r is. It's 3. And we know what n is. It's 11. So I can just substitute all of that in. And if you put that on the calculator, you should get 29,000. Okay, 295,245. That is your 11th term. Okay. Example 2. Determine the GP. Now GP just stands for geometric progression. You can also get an AP, which is arithmetic progression, which is your common difference. Okay. Okay, so just watch out for these things. So determine the geometric progression of which the third term is 5 over 2 and the sixth term is minus 5 over 16. Okay, so let's see if I can fit it in on this page here. So example 2. Just want to write down our general formula. Tn is equal to a times r to the n minus 1. All right, so they told us that our third term is equal to 5 over 2 and our sixth term is equal to minus 5 over 16. Now this is very similar to what we did with the arithmetic ones, where you get your two equations and then you can solve for it, okay? So what I'm going to do is I'm going to take the 3, plug it into the formula over there, and we get a times r to the 3 minus 1 equals 5 over 2. And then likewise for this, take the 6, plug it in for our n, and we get a r 6 minus 1 equals minus 5 over 16. Let's just simplify this. So we get a r squared equals 5 over 2. And here we get a r 5 is equal to minus 5 over 16. Okay, so this is equation 1 and this is equation 2. Now, with the arithmetic one, you remember you substituted the one into the other one. With this one, it's going to be a little bit different. So what I'm going to do with these geometric ones is I'm going to rather say equation 2 divided by equation 1. Now, the reason why I'm going to do that, grade 12s, is if I take this side, this AR to the 5, divided by this AR squared, I can see that the A's will cancel and I'm left with just one variable, which is R, okay? So that's what's going to happen here, is I'm going to take this divided by this. So the A's will cancel, and then you've got R to the 5 divided by R squared. Now remember, if your bases are the same and you're dividing, you subtract the exponents. So here we'll be left with R cubed equals. On your calculators, you can take this minus 5 over 16 divided by 5 over 2, and you'll get minus 1 over 8. Now, in order to get the R on its own, you need to take the cube root. What you do to this side, you must do to this side. So the cube root of minus 1 over 8, we're left with R is equal to minus 1 over 2. All right. So the question was, determine the geometric progression. So what we need to do is we need to find the first 3 terms. So we don't know what our A is yet. So what I'm going to do is I'm going to take this R, plug it into equation 1. So let's just say here sub into 1. Okay, so we get A times minus a half, because that's what our R is. We calculated it over here. Squared equals 5 over 2. On your calculators, you can just say 5 over 2 divided by minus 1 over 2 squared, and you'll get A is equal to 10. So now we've got our first term, which is 10. How do we get from term to term to term? We multiply by minus 1 over 2. So 5 times minus 1 over 2 is going to give us minus 5, which is our second term. To get to the next term, I multiply that by minus 1 over 2, and that will give us 5 over 2. And all you have to do is just list the first 3, and that's fine, and it carries on. Okay, let's have a look. See next, example 3. The geometric sequence 1, 2, 4, and so on has a term equal to 128. Determine the number of the term. Okay. So, example 3. We've got this 1, 2, 4, and so on and so on. Okay, just write down the general equation. Tn is equal to A times Rn minus 1. Right, so grade 12s, what I need to do is I need to find out how am I getting from term to term to term. So take this one divided by this, and we get 2. So I'm multiplying by 2. Take this divided by this, and I get 2. So I'm multiplying by 2. And you can see it's a constant ratio. Okay, so what I'm going to do is I'm just going to plug everything into our general formula here just to find out what our general equation is for this sequence. So Tn is equal to, our A is 1, multiplied by our r is 2 to the n minus 1. I can simplify that to be 2 to the power of n minus 1. Okay, so somewhere in this sequence, down here somewhere, lies this 128. So I'm going to take our general equation and set it equal to that 128 and then solve for n, and that will give us our term number. So we're going to get here 2n minus 1 equals 128. Now this is going back to grade 9 and grade 10 work. What we need to do is we need to get the bases the same. So you remember you need to prime factorize this 128. So we get 2 to the n minus 1 equals 2 to the power of 7. Now because our bases are the same, we can equate the exponents. So therefore, n minus 1 is equal to 7. Take the minus 1 to the other side and we get n is equal to 8. Therefore, it's the 8th term in the sequence is equal to 128. Okay. Example 4. Determine the geometric sequence of which the 8th term is 896 and the constant ratio is 2. All right, so example 4. They told us, I just want to write down our general equation first, a r n minus 1. They told us that our 8th term is equal to 896, and they told us that our constant ratio is 2. All right. What we need to do is determine the geometric sequence, so we need to find the first 3 terms. Okay, so what I'm going to do is I'm going to take this 8, plug it into here, so we get a r 8 minus 1 equals 896. Let's just simplify this and we get a r to the 7 equals 896. I can call this equation 1, call this one equation 2. I can sub this equation 2 into equation 1 and solve for a. So sub 2 into 1, and we get a 2 to the power of 7 equals 896. I'm just going to, on the calculator, divide 896 by 2 to the power of 7, and we get a is equal to 7. So now I know what my first term is. So the first term is 7. How do we get from term to term to term? We multiply by 2. So this multiplied by 2 will give us 14. 14 multiplied by 2 will give us 28, and it goes on. Okay, remember you just have to list the first 3. Okay, grade 12s, what I would like you to do for homework is exercise 1.4 for me, please. Thank you.